Let me address that because that's I think worth some discussion here. So again, as SDN grows, and we spoke to in the very beginning that it means different things to different people. A lot of focus, of course, in early SDN work and through the ONF is on OpenFlow. And if that's your view, SDN is sort of defined by OpenFlow, then you would say the success or failure of a carrier being able to install it's going to be the ability of that carrier to influence their large vendors to open up to OpenFlow. I'd say we should do that, but I wouldn't rest my success or failure just on that.
Yeah.
SDN to me is broader than that. OpenFlow happens to be a protocol that was aligned with this architectural view early on and is moving in a nice direction to take on more and more features that carriers and data center operators need. But it is just one protocol. And 20 years from now, we could be sitting having this discussion and we might be lamenting that there's only 2 or 3 big players left because of the consolidation. It's natural.
Yeah.
But there might be 5 or 6 other protocols that we haven't even invented yet. And OpenFlow may be one of them or may not be. It's certainly one of the early ones now. We look at SDN broader than OpenFlow. I mean, we consider a lot of the work that we've already started doing in laboratory and moving to field as SDN, but what we're doing is not necessarily controlling the wide area network infrastructure. We're viewing it as sort of the static connectivity. But rather than use all of the hooks and capabilities that have been built up in MPLS and IP, in terms of a lot of sophisticated capabilities for service have been pushed into those layers. Instead, we just look at it as bare bones IP routing, and we're providing the QoS and service-aware capability on top of that. All right, so it's an overlay, and it's therefore not going to get to the ultimate efficiency if you could also use a protocol like OpenFlow to control the topology. And so in this case, we're sort of mapped to a constant topology, but we're not relying on the IP MPLS structure to do the routing per se. We're doing it at a software layer following SDN. So to us, that is SDN sans OpenFlow. That's okay. That's a step.
I mean, to add to what you just said, Stu, for us, SDN is much bigger than OpenFlow. OpenFlow is protocol of choice. And one could argue that OpenFlow is the same protocol of choice for IMS, which is SIP today. So, as I said earlier, it's 3 things for us, the service provider SDN. It's an abstracted control plane, it's about service exposure, and big data analytics to provide an excellent end-user experience. So it's...
Yes, I mean, I completely agree with the view that OpenFlow is not the same as SDN. I think OpenFlow is an enabler, an important enabler. I think it's something of a catalyst for the whole SDN movement.
Sure.
But it's certainly not the only SDN protocol. I think people tend to forget that path computation element is a concept that predates OpenFlow by about 3 years and takes a much less radical view, whereas OpenFlow dumbs down the data plane almost completely to just a pure data forwarding engine and puts the entire control plane elsewhere. PCE says, let's take the really difficult thing, which is computing end-to-end paths through the network that are traffic engineered. We'll put that somewhere else because that's the thing that's computationally expensive. And we'll leave all the other stuff, the topology discovery and so on, in those network elements. So less radical, maybe ultimately less capable, but a much safer bet from the point of view of introducing into existing networks because there's much less disruption. So I think there'll be some evolution in the protocols. I think OpenFlow will get more sophisticated. I think path computation element protocol will get more sophisticated. We'll see statefulness in PCE controllers. Maybe the 2 protocols will sort of come together and meet a little bit in the middle. But I think they're important because they do allow for multiple vendors to play in this space. That they have to be seen, therefore, as important enablers that allow an SDN controller from vendor A to talk to network elements supplied by vendors B and C. And that does seem to me to be a pretty important requirement, if you like, for this whole SDN thing to become successful.
Yeah, absolutely. But I still believe it's bigger than splitting the architecture as well. Splitting the control plane and the forward plane. We've done this in the wireless network now for many years.
And in the voice network, of course, 15 years since soft switching came in.
So it's why we do emphasize there's that SDN, I think it's bigger than OpenFlow and just splitting the control plane from the forward plane. It's basically tying, to your point, everything end to end together to provide an end user experience at the end of the day, lowering, OpEx, CapEx, and increasing revenues.
Yeah. Well, I mean, there's sort of a fundamental opportunity I think SDN architecture has, which was in front of us years ago with IP, and it just wasn't realized, right?
No.
Which is to really separate those planes appropriately. You separate address spaces, and what's happened just through implementation, velocity to market, IP and IP addresses, which were really, I think, the network attachment address became the address all the way up to a service, right? And that immediately then puts constraints on what you can do and how you can do it.
Yeah.
When you think about SDN, you really are separating the underlying address structure and way you move the data, the packets through the network or the streams through the network from your services layer.
Right.
That's important. I mean, that's something we've done in other networks, as you said. We've done it in the computer world forever. It's the way that you really get to scale and flexibility of new services. So you don't have to go back and rewrite all your lower layers every time you want to introduce, a new service. That's very important. The other piece of this I'd add, though, it's not just how SDN's viewed in the network sense, whether it's OpenFlow or PCE, but it's really getting to the environment and realizing that just about all services, certainly on the consumer side and moving towards business, are running through data centers at this point.
Yeah.
We can call them different things. We can call them, the next generation of central offices or POPs, but they're data centers. When a consumer is typically going through a CDN to get to, the Facebook or the Google or wherever they're going, and all of that's data center sort of equipment. So the network and the data center really are, from a service experience point of view, tied together very tightly. But they're not operated that way, and we don't typically think of them that way. We have data center guys, and we have network guys, and in the case of Verizon, they're in the same company. In many companies, it's different companies supplying the data centers and the pipes. But from a customer experience, it all has to work. We have to find a way to make it work efficiently and low cost and add value. And SDN again provides that framework to move from data center into wide area and operationally, which in terms of service creation, in terms of provisioning, in terms of monitoring, in a unified fashion, as opposed to two different stovepipes, which is how it's operated today.
Yeah.
So I think that's sort of one of the big reasons that a company like Verizon is interested in SDN, is we have the data center assets, as do many other carriers. We have the network assets. The answer, 1 + 1 is going to be more than 2 in this case, but it's going to take a new sort of framework to tie that together.